Okay, short practical this week, but what I want you to do is actually change the way that you plot this. So I'm going to get you to plot the results from these two quick experiments on the same graph, but in two different ways. So which way is the better to find the value of our unknown capacitor? Okay, so one's going to be an exponential, and then one's using a logarithmic graph to get a linear shape of graph. Okay, we've got a 12-volt power pack. Got a timer, we have our voltmeter there, and here is our two circuits. So I've got a charging circuit, so when I connect across this gap we're going to charge through the bottom rail at 12 volts. Okay, so we're going to go through the resistor that I've put on this limb here. When I connect it here instead, what I'm going to get is I'm going to get a discharge circuit. Okay, and I'll move the lead just to make that easier at that point. But I'm going to be discharging through the same resistor. Now, the capacitor, whichever method you use, should give you the same result, obviously, but it's also the same as the unknown capacitor from last week. So you can verify the result, verify that and see if you get the same value. Okay. Now, as you can see, we've got a little bit of charge on my capacitor, so I'm just going to take a lead and I'm just going to short out the two connections. Doesn't matter where I do it, there or there, there or there. So we'll take out any charge in the capacitor itself. And what we're going to do is start the stopwatch. And what I want you to do is just freeze the video. You can't do this in the classroom, but you can freeze this. So every 20 seconds, say, take a reading. If there's too many, then you could do every other reading. Maybe try it through first. So when this gets close to 12 volts, you're almost full. 3, 2, 1, go. And as you can see, it's taking a long time for that very last little part. So what I'm going to do is stop it there. Reset. Okay, just going to swap the leads around to make it look a bit neater, but we'll discharge through the resistor now. There we go. We've got it permanently on the power supply, so we've got it at 12, and as soon as I, 12.5, as soon as I release that, one of these leads, then what I'll get is the start of the discharge. So We've got it already connected, so it's got a complete loop. 3, 2, 1. He says start that again because I can't get the lead out one-handed. There we go. So 3, 2, 1, go. Just to make it easier, let's get that one out of the way as well. Okay, so with those results, plot two curving graphs. There we go. I won't go all the way down to 0. So plot two curving graphs and then use logarithms, find the log of the voltage here to plot against time there. And I should obviously say, but you already know, time in seconds. To plot them, one will give you a straight line graph. Hopefully you can trust that result. The other one, try it and verify it. So don't forget 1 time constant and find 2 time constants, and 3, use that repetition technique. Okay, we'll finish it there. Thank you very much, and I'll see your results.